We will now evaluate this integral, that is integration of dx, and verify the result by differentiation. So let's see how to integrate this. I'm going to write down this as integral of 1 dot dx, because I assume that dx could be written as 1 dot dx. So now both are exactly the same. And in the next step, I'm going to write down this 1 as x power 0 dot dx, because 1 is equal to, according to the exponent law, x raised to the power of 0 is 1. So you can write 1 as x power 0. Now we have to apply the power rule of integration. So let's revisit the power rule of integration. Suppose if we have to integrate x power n dx, the formula says it is equal to x power n plus 1 divided by n plus 1 plus the constant of integration c. So this is the formula. I'm going to apply this formula here to integrate this. So I have x raised to the power of 0, which means n equal to 0. So when I substitute into this formula, I'll be getting x raised to the power of 0 plus 1 divided by 0 plus 1. And then I put the constant of integration plus c. So this is equivalent to x raised to the power of 1 divided by 1 plus c. And when we simplify this, this is equal to x plus c, which means the integration of dx is x plus some arbitrary constant. We will now verify this result by differentiating x plus c. So we have to differentiate x plus c, and when we do that, we should get back our original function, that is 1, because that's what we started off with. When we integrated 1, we got x plus c. So when we differentiate x plus c, we should get back the original function, that is in this case 1 here. So I'm going to split this as two differentiation, that is d by dx of x plus d by dx of c. And once again, I'm going to apply the power rule of differentiation. Remember that if you differentiate x power n, the rule says it is equal to n x power n minus 1. So in this case, n here is 1, because x is equal to, I can write down this as x raised to the power of 1. So n equal to 1, which means if I differentiate d by dx of x power 1, I put the 1 in front and then put x and then 1 minus 1. And plus differentiation of c is basically a constant. So differentiation of constant equal to 0. So this gives 1 x power 1 minus 1. This is x power 0 plus 0. We can ignore that. So it's basically equal to x power 0 equal to 1. So 1 dot 1 is 1. So we can see that we differentiated x plus c and we got back 1, which means we have verified the result both when we integrate 1, we got x plus c, and when we differentiated the x plus c, we got back the original function 1.